All right, welcome to yet another episode of Inside Dfinity. I'm still in Palo Alto with the Dfinity team, and today I'm sitting down with Ishwar.
Hi.
Maybe a very simple question to start with. What is it that you do at Dfinity?
So currently I'm an intern for the summer here, but otherwise I'm a PhD student at Purdue, working with Professor Aniket Kate. So I'm here for this summer.
Okay, and what is it that you've been working on here at Dfinity?
In Dfinity, like one of the problems that I've been trying to address is the problem of DKG or distributed key generation. If you look at the system, they have different nodes who actually sign certain transaction with a share of a key. And DKG is a mechanism to give the share of a secret key to each of the users. And we are trying to come up with a scheme which scales to huge number of nodes. And so that still the load on the network is pretty low. The amount of data, the communication complexity is pretty low. So that is the problem that I've been working on here.
And just so that so that people can follow who might not be familiar with the term, DKG means distributed key generation, right?
Yes.
Yeah. And when we talk about keys, those are cryptographic keys in a public-private key kind of setup.
So one beautiful beauty of this distributed key generation concept is everyone will have a share of the secret, but no one has the complete secret. And for anyone to generate the complete secret key, at least a subset of the users need to come together.
And that's important in for the validators in Dfinity's consensus.
Yeah, so every validator or dealer or every node in the system signs the transaction using his secret key share, which is aggregated, the signature share is aggregated later at some point.
Cool, so before we further dive into how we're solving this problem or what exactly you've researched and maybe some of your findings of this summer, how did you mentioned you're a PhD student at Purdue, how did you first hear about Dfinity?
So I was there at a conference called BPACE in Stanford where Timo and Monish gave a talk. So later I was discussing with my advisor and he suggested that I write to Monish. And after that, I wrote to Monish and spoke to Monish and Timo, and that's how I'm here.
Cool. And in what field are you doing your PhD research?
So, yeah, I mean, broadly it's applied cryptography, but more specifically onto multi-party computation protocols with applications to blockchains and other blockchain systems like consortium-based blockchains or permission blockchains. And related in the problems related to this field, yeah.
Besides, so from your perspective, doing research in that field, besides Dfinity, what are some other projects that you've closely followed or find interesting or?
So, I mean, there are a lot of interesting protocols and systems that are coming up, and I think there's an exponential growth of such systems. But specifically, I really like the zero knowledge proof concept and systems which use zero knowledge, Zcash and other systems. But there are also different other applications like SIA is a project which distributed storage, and then there's TrueBit, and of course Ethereum, which is growing continuously with people contributing different ideas. So I try to follow as much as I can, though not completely, because there are so many ideas out there, so many people working on it, and all are really interesting.
That's something that I face. Like a lot of people, of course, now that I spend 100% of my time in the blockchain space or on a blockchain project, like they come up with all kinds of projects and they ask me for my opinion, and very often I have to default to saying, I don't know the answer, I don't even know the project, just because I feel like I'm so focused on moving us forward and kind of internally focused that I don't have the time or I don't take the time to observe this space like I used to before when I was comparing multiple projects. Cool, so what's next for you? I think you're ending your internship here in about 2.5 weeks if I'm...
Yeah, in about 3 weeks, so I'll be back to Purdue and working on my thesis problems and any interesting problems probably that I take away from here.
Yeah, so maybe let's dive in a bit. What are some of the problems or ideas that you deep dove during your time here, during your internship?
The DKG problem itself is a very interesting problem, and especially when you have large, huge networks. The protocols that have existed till now are either interactive in nature, where the communication complexity grows higher with higher number of nodes, and that is one thing. So we are trying to use some zero knowledge proofs so that a dealer can generate a share and just put it on the blockchain saying, okay, you also give a proof saying that, okay, these shares have been generated properly. So the takeaway from this whole exercise for me would be the knowledge on zero knowledge proofs, where in confidential transactions, people have been using this zero knowledge in a lot of other schemes, and I think it has a lot more potential than what could come up. One thing is proof of computation. Many people are attempting to actually solve proof of computation efficiently. Till now there are schemes, but not so efficient so that it can be deployed in wider networks. So that is one thing that I would really probably knowledge on that would be my takeaway from this.
Mentioned the term a few times, zero knowledge or zero knowledge proofs, right? Could you maybe, for those that are not familiar with the term, because I feel it's a term that I hear very often in the blockchain space.
So zero knowledge is a very interesting idea where you prove you know something without actually revealing what is that you know. So it's a very simple example I found online, one small game. Say there is a person who is colorblind and he is holding two balls, one is red and one is green. And the other person says, I know that there are two different colors. But the other person is colorblind, he says, prove it to me. So one thing that he can ask him to do is, he says, okay, take the balls, put it behind your back and then shuffle them. I will tell whether you have shuffled or not. So every time he shuffles, the person who can see the color can tell, okay, you have shuffled, otherwise you have not shuffled. So that's how I can convince the other person, I know that they are of two different colors, without actually telling him or giving the apparatus to actually differentiate the colors.
Right.
So this is one fun protocol, but there are more complex protocols.
Very cool. Do you have other analogies? Because I think these are extremely helpful for people that haven't spent that much time in the space to understand the concept. Besides that, like concept of the colorblind person and the two balls, are there other concepts that can be used as an analogy for zero knowledge?
Usually people, I mean, I have seen many people quoting some standard examples like, I know a solution to a problem like Sudoku. Say you give me a Sudoku puzzle and I say, okay, I know the answer to it. One way to prove that I know the answer to without revealing the answer is just map all the numbers in a one-to-one mapping to another Sudoku puzzle and trying to reveal one row or one column of the puzzle at a time. So every time you ask me to open a row or column, you will see, okay, it actually holds a certain property.
Yep.
But before every question, I actually reshuffle the Sudoku again. So that will convince you that, okay, I know how to solve a Sudoku and probably I have the solution to this Sudoku.
Very cool. What are other hard problems or like terminology that might not have reached like mainstream, because like zero knowledge proofs is something that like recently just gained a lot of popularity, I feel. What are some other concepts in cryptography that are just have seen a lot of research going into it?
So I think that that's a very intriguing concept and very interesting in the sense that, so the main aim is like that. Say you have your salary, I have my salary, and we need to know whose salary is higher without actually revealing our numbers. This problem is like called millionaire's problem, has been there for a very long time. But the idea is that we all should be able to compute something, some function, without revealing our inputs. Where privacy, like this is one beautiful feature is that my inputs are private to me, I'm not revealing the information. So multi-party computation protocols are gaining ground, like coming into the practice. Till now they haven't been much, I would say, because they're very complex in nature. But with these zero knowledge proofs and so many other things, I think they'll also come into practice. Like I would love to see all of them in practice. I also hear from my friends that certain big companies are trying to get these protocols into design and systems like that, where you try to design an object without actually revealing the actual final product. So you say, these are my requirements and what is your input, can we do?
How did you first hear about crypto and blockchain, and how did you first get involved or fascinated by it?
When I joined my PhD, I was broadly interested in security. I didn't pinpoint any problem to work on, but then I attended a course or a few talks from my professor who works on blockchain and anonymity and other networks like that. So I got very interested.
And how long ago is this? When did you start your PhD?
I started in 2015.
2015, so
yeah,
3 years ago, roughly.
Yeah, but I started working with my professor from 2016. I took my time, I ventured into all different flavors of security. There's theoretical cryptography, there is applied cryptography, and there's system security. But I felt blockchain has really is opening up a great deal of problem. I mean, it's opening up great opportunities, and with that, many challenges, many security and privacy challenges. I felt those are like, and with direct implications to people. So when you build a big crypto system, if you see Bitcoin, it has penetrated into the world, and any issue with Bitcoin affects all the people at once in one single shot. I think trying to address these issues, I thought it's very, it has a huge impact on many people at once. So that's how I ended up into blockchains and cryptocurrency.
And after hearing about Dfinity or the problems that Manoj and team are working on, how would you describe Dfinity?
So Dfinity is a wonderful idea where they're trying to take blockchain and do something awesome. So they plan. So I mean, in my words, I think they can explain it better. But in my words, what they're trying to come up with are basically a computing system where anyone can submit certain transaction and certain computation and just get the results out. I mean, I think this is how you explain any blockchain system, but the beauty of Dfinity is the threshold relay and how the pseudo randomness is maintained across different epochs, and the consensus algorithm, which is very fast. And I think the way they are implementing, I really intrigued about this WebAssembly, how they deploy the modules in WebAssembly and get the system running.
Pointed all in all the right directions. What I was going to say is that it just makes me, every time I talk to someone and I ask them this question, I realize A, how far we've come, but also how much we still have to build. Yeah. Because it's such an interesting world full of like open questions and interesting problems to solve.
I mean, at least for a student like me, it feels very exciting to see problems because I have something to solve.
Great. Well, thanks a lot for your time and answering some questions, and of course for all your inputs during the summer. It's been very valuable. We didn't have too much overlap over the past 2.5 months, but I've seen your work here and there, and I'm super excited to see it come to fruition and be part of hopefully what Dfinity technology will bring to the world. In case you're also interested in joining Dfinity as a student, PhD student, whether doing an internship or full-time, then go to our jobs page under dfinity.org/jobs or reach out to some of us directly. You'll find some of the team members on our website. And with that, we'll talk soon.